We're here.
Good afternoon, everyone. How is everyone doing? Great, great. Some people need a lunch coffee, or they are still doing all right. Little bit of energy, that's good. So I'm Matthias, architect to it, and I'm here to talk about fine-tuning and Gemma, and how together in a customer experience setting. I was reading my description this morning, and I realized it was very recipe focused, and we're a long way from that. I wrote this thought description 2 months ago, and it turned out to be more of a random walk trying to make. But I think there's still a lot of interesting findings, and I hope you guys enjoy what I did and the things I will walk you through. So, a little bit of Gemma, where we're going to look at. I'll walk you through the introduction to Gemma, swiftly and briefly. I'll introduce you to the use case, why we do fine-tuning, and some other optimization techniques that I think are interesting enough to frame the whole discussion. We'll look a bit in prompt optimization, which is the first thing I tried, and a library called ESPY, which maybe somebody familiar with ESPY. Little bit, I see one hand. Okay, so at least I'm gonna teach some. That's good. Then section 4, we'll talk a bit about fine-tuning, which I guess most of the people here are here for. And then I have quite a few learnings that I have from along the way, like to share with you. So without further ado, Gemma. What is Gemma? And a little bit of an overview. Some of you might be wondering, did you misspell Gemma? I did not. What is Gemma? Who's heard of Gemma before? Okay. That's a one people. But probably a lot more of Gemma. Gemini is kind of like that is Google's best model running on Google's infra, while Gemma are the open models available for downloading and experimentation. Brief section out what all text are. And there's a few flavors to open models, and it relates to how are they accept. So some models are open weight. Gemma is an open weight model, where you get basically parameter from Google, and you can load them and initialize them as a model yourself on your local machine on any hardware you have available. Some other models are open code, so that's where the model trainers have provided the whole architecture, training, and inference logic. And if we go further, some of them can share the data that they use to train their models. I think this is quite rare because maybe licensing issues, things like that. And lastly, the most open way would be to share the training procedure, where you can take the data, take the hyperparameters, and reproduce the whole model on your own hardware. But there's not that much. I think it's more academic. Few other models are there. There's not Gemma. There is Microsoft Pi, there's Mistral, there's even OpenAI has their own models, and a few from around this side of the world. This side of the world, I think, is made some waves a while ago. One from Alibaba, there's Gemma, also very popular, and the Middle East has their own Falcon stack. You can find it on Alamarina or just in people ranking them and stuff. So to learn a bit more about what's out there. So why do we put this interest in small models? Because big models kind of give us what we want, right? Well, not always. If you're asking a trivial prompt like generate a random color, a big model is all their computation, which is pointless for the task at hand. So therefore, it might make sense to look at your use case and take a smaller model that lower complexity and lower calculations. With that comes customizability. So if you pick an open model, you can take your own data sets, and you can customize the model for your own use case. Maybe getting the same performance as a big model, or even better in the process. And with that efficiency, so small models use less computation, it lowers your costs, might lower your latency, and if you happen to care about that, that's gonna burn less coal and less fuels that will give us a better environmental impact. What's also nice is you can take the model, you can deploy it anywhere. So my case is on my machine, just running Llama, small model, fiddle with the code and the code came out. But for some cases, your customer happens to be careful with their data privacy might have consideration. I don't want to send all your data to one of the. So you can take the model, you can take on your own hardware. Brief Gemma history. I'm going to go into that. There's basically three different generations in the last 2 years. There are multiple Gemmas released. So today we're going to concentrate on the top ones. So models, which comes in 5 flavors, 5 different sizes. But there's also other models like the ones that specialize in embedding. Some might specialize in medical use cases, or there's ones that goes beyond edge inference. And then where to Gemma? Where to play around with these models? One way is OpenAI. I think that's the easy start. Then you just generate your and start talking to the model. I think it just removes from the UI, which is a little bit annoying, but still there. If you into your environment. Then Vertex AI, a little bit more work to get more learning. You get more learning. Actually, your own infrastructure. You take the infrastructure, how many accelerators, how much hardware you want to load the model onto, and then you can start doing inference. And then lastly, Cloud Run is the service solution Google has, which was specifically applicable because my application is running there. It now comes with serverless GPUs, so you can just load your model, small ones, start doing inference. So use case. Before we dive into solution, a little bit of context. This was something I did on my work, where we delivered the true code, making it more accessible, which comes as two parts. The on-demand, at least 150 cloud architect. So basically, how does that happen? When you start architect? They should start video. Here we go. So basically, this is the user experience. You have a form where you describe your and there's a bit of metadata that comes with. So instead of having fill out all this whole form with get a little bit. We let them just their and then we do inference on what the severity is, what you're talking about, what the platform is, and with that, sometimes it's with creativity. We also ask them some like, okay, my database is talking about what query were you trying to do, what project is what database is located. So the idea behind the project was to move away from like customers doing form filling, way to spend your time, and and the architect on the other side more context about the problem that is coming towards them. We invested a bit of time and money into cost optimization, which you can read about here for today. So the problem I wanted to get my conversation was actually because not all the requests that come from the customer are related to a certain thing that is going. They might also be related to cost optimization. Maybe you want to have creating a POC. Maybe your migration from SSP or the other way around. So not all requests are equally bored. So we find some classes, and this turns the classification problem 7, which on our end will affect routing. So on one end, maybe some people are more specialized in cost optimization, so we want to route them. Some people are specialized in Google Cloud, some people are specialized in AWS. So that will affect the routing in the backend. On the other hand, it will affect user experience because we might not want to add technical details for POC. There is not a certain database or they might at least need it. So we had the system. We also want to start collecting some data. For that we have which is application captures the data from the architect to get feedback on the system. And that's basically where the ticket type classification journey started. So the first step to solve the problem was optimization, and I saw a lot of people think their own way of doing this. Maybe you've had a colleague that has developed a similar system and they get some feedback, they like it down a little bit, by doing that they use five other problems. That's something I really didn't like. I wanted to stay away from, so I decided to take a bit more structured approach, and that's how I ended up looking into the SPY. So what is the SPY? Basically a framework developed framework stands for declarative self-declarative Python, and it helps you with building kind of an undirected search to do an optimization problem. How do you do that? It comes with a word that helps you find a signature, which is basically the system that you're trying to optimize. It's a declarative specification of the input and output, and the prompts that you are going to give. So it's kind of an abstraction. It comes with the building blocks that use an LLM to get to a certain result. Can be react. So they're kind of built into the SPY. The signature looks a bit like PyTorch, and you can compose programs and then optimize as a whole. Give it these two things. Also create a data set and then optimize. That's your work. So what does this look like? I really like this. So it's a class with your string. And basically this is what you're going to give. My case was your fire, you describe the categories, and then you tell it your input is going to run on the data description, and the output is going to be a certain ticket type. These are the values that are valid options. The modules that I use was just a simple synthetic and also a chain of thoughts. And then we started doing optimization. So how do the optimize work? It's basically rewriting instructions and getting examples to tune your modules to maximize to a certain metric. So there's a bunch. I think more than 10. I tried different ones. One is a few shots, which we automatically select or generate few shot examples for your problem. The second one I looked to call probability. So that one looks really the properties of your data set. program code and examples to generate new instructions with a more powerful model. So it takes maybe a GPT-5, Gemini 2.5 console, and use that to look through these details and adapt your prompt. Similarly with Gemma, but it takes a different approach where it looks at the examples that are specified and uses that as a feedback for the model rewriting the instructions for as well. They come with two papers, so they come with deeper, that's for you read. But on to results. So in my first experience, I tried to run the DSPY optimizations on Gemma 27 billion, as well as running them on AI Studio and Vertex AI straight out the box. And the results were kind of interesting. So my one score for the 27B model went up from 27 to 54 with bootstrap increase. But then the other experiment, I saw a decrease in performance with an increase in models. And I think I should have known something was not entirely right. But I kind of ignored it at that point, and I was kind of driven by curiosity, not so great results so far, and the promise of being able to go label data set as my model and getting a lot better results. So that's when I started going into fine-tuning, also another journey without outcomes. So what is fine-tuning? Basically, we take a model and we post-train it for certain task adaptation. There's full fine-tuning, but nowadays, if you talk fine-tuning, most people are talking about parameter efficient fine-tuning, or PET, which is a way of fine-tuning where you reach most of the parameters and only train a few ones. Two techniques were very popular. In LoRa, you kind of take a certain part of the weight and decompose them into low-rank matrices that then get trained, which is a lot less parameters to train compared to the full model. LoRa basically does the same, but on quantized. One interesting thing to note there is that Gemma models also very easily includes quantization where training models, which are really interesting to look into. So, more in the diagram, so the whole big weight matrix here, we compose them into small matrices and we just train on these, which makes the optimization problem a lot smaller. As I said, this is not the only techniques out there. There are other types of optimization techniques that add layers. There's a good blog post about this if you want to read more about this visualization. So what do my experiments look like? So I started with enterprise, which is a managed environment on cloud. So you can easily connect to a runtime that has some acceleration ready for you to play with. For code I use, or for library I use Keras, which is a open source high-level learning API for fast experimentation. I got my model from a lot of other stuff, data sets, other models with community talk, and pre-node program, which is quite interesting. And then lastly, deployment of Vertex AI. So there you can take a model on a model, you can play with it, but also deploy it, and when it's fine-tuning, you don't want to go through all the trouble to fine-tuning yourself. So results. You're most first try just the one big model, and small batch, like one batch size, and it basically learned nothing. So it kept outputting full responses instead of just labeling that I was looking for. So what's the obvious thing to do? Use more force, train for some more people, and the result is completely over. Learn way too much, and it was just only on one class. So far, I think it's fair to say there was a fine fiasco. But then I realized working with only one labeled examples from my colleagues that were labeling data. And it took me first of all to look into my data set, was quite imbalanced. So there was bias towards break fix class. I think were break fix. Half of the examples were break fix, and some of the training data I think didn't know where it was going. And that's when I decided to look into making synthetic data sets. So I power models. I let them do inference and decide the labels themselves, and I calculate in alignment with all the full data set that I had at that point. That resulted in 77% accuracy or going of 64, which is 100% alignment, and I looked at the examples where all the models agreed. The number even went up to 83 and 0.72, which is quite reasonable, I think, to work with. All the models agree. So new results with data sets, I think out of the 100,000 examples I got in this data set, about 100 were left. And the result was a bit more encouraging. So we managed to get a 40% performance increase from 53 to 64 on our one with one people. But on the downside, most of the game was starting to better predict the dominant class. So that's kind of the downside, because this is something. Okay, this is you get a high chance of getting it right if you, in my case, predict things. So it's a reasonable outcome for having the technical details. We can still request technical details for the customer, but maybe not to impact product. Then I also decided to rerun the experiments on the bigger models, and actually there, Gemma 27B with GSPY, the might be too weak. Because the winning combination resulting in 90% score, which fairly good. I also read fine-tuning in Vertex AI, but the fine-tuning didn't work, so I didn't get to that. Maybe next time. So, conclusion. There's a few things that I'll evaluate doing this. So a few practical takeaways. For me, the experimentation was not a linear process. It was more of a random walk. I learned that a lot of the details are abstract. The way when you're using a management things like your special tokens to delineate the interactions, sort of model. They are abstract. Also, schema is not included everywhere. For example, AI Studio, of course, there's no schema. What Vertex AI there is, and that to full string decoding when I was fine-tuning with Gareth. I lost a lot of time there. I think the next point is discipline pays off. So it's good to have fine experiments, to take your results, and to version control your data set. Like I think that's where I lost my time. And yeah, I would encourage you about it when you start. Practically, I started off. I don't know if we know this guy. This Llama running a one Gemma on my local possible, and I could get the code right without a big machine in the cloud first. So that was really useful. Check your data. This is another thing I would encourage you. Without being aware of basically training on a very data set, which with us. Use selective certified training and test sets. And if you're in a position where there's not abundant data, maybe synthetic data is really helpful for you. Yeah, there are many options. I think we're lots exercises. There's so many libraries, so many different techniques you can try. I think this big one, commit, where you end up, see where you end up, instead of like trying to learn about them all, basically shotgun like a side. In the end, I can say we can do a very good job at Gemma. In Gemma, so small optimization, model 90%, which I think enough for it's fair to say fine-tuning has in your headset. It can improve small by up to 40% in my case. And so does prompt engineering. Gemma's performance at the end. So it was quite disappointing. And I think the whole thing you have to live with. You cannot have a small model running because that's approximately price of 127 and performance. But for us, the decision is quite easy because one billion parameter is the only option right now. I think there might more GPUs. For now, it's only L4s. And then latency measurement experience for small might look better than for the big model. And with that, that's my talk. You can read about optimization of the inference on my blog and chat after answering.
We share property that and we use what you have done.
Yeah, not first of all, because I was basically still working on this until last night. This is very much work in progress. Secondly, you would probably never do reproduce because I'm not on the sharing data. So one thing I want to do because there's a lot of stuff out there online. Let's just try this on a kind of tested data. I can protect the result of it. But I don't think my company is gonna make our description. It's bad.
Maybe 7P can be download in outdoor. I'm afraid.
It's on Kaggle. If you can reach Kaggle, you can probably. It's. Can you reach Hugging Face? Then you should be able to. Kaggle doesn't seem to be very strong. I'm not sure about that. I just arrived. I need to try. Yeah. Okay. I think it should be possible, and also Gemma, there's other open models. I know this is a Google conference. I know you're still free to choose other models. Yeah, I think there's all the like wine could be an option. Yeah, I heard good things about. Yeah, it's available. We'll try.
It's not image or image.
only text at the moment. So some of the this is also funny. Some of our descriptions basically foreign coded images with like. So Gemma was up to 100 context windows, but I think for some of the groups that included a lot of images, still too much. But I think they're multiple. The models above 1 billion parameters. So 4, 12, and 27 are multimodal, so you can use them.
Thank you. Thank you.
That's all. My question is about what do you think is SL small language, because nowadays working on lots of I would say it's very much because open negotiation work over there about 10 plus no LLM, which every time if you look out, it may take 20 seconds or 5 seconds. So I think some of the current way how they optimize the overall workflow is they just all and the so try to minimize the time. So do you think end user or for example for every agent workflow they be fine to perform that task?
It's a very question. Because basically, each one the workflow you're trying to do, maybe what you do or what's not next, right? So I think it goes back to alcohol and workflow. I think a lot of people are expecting magic from tools and the tools, and they're not always magical. At each point in your look, it was in your workflow, something I think it makes sense. In one sort of this in accuracy, like take at least any right decisions and we can the feedback from signals to that. I think this if I figure out the right way to drive, I think small language models do have a place. One thing we were struggling with we started. For the first version of this system, we used for quality. During the whole network, small language models, in Cloudrun, L40 run Gemma. So I do think for this role. In some way, we're taking this back to require more data. We are looking at what's happening across any other and
those fine-tuning feels like we are going through the Gen AI things like all classified.
Yeah, in some ways it doesn't. Yeah, in some ways because basically companies.
Hi, thank you for your talk. I have this. Did you find your findings?
So I find 27 ones that I find.
How much is that?
We can check the console. I didn't check. Yeah. That part worked. I don't know why. The serving containers. I didn't figure it out yet.
Roughly how long?
It was fairly quick. You want to check? You can check later. I don't know off the top of my head.